Hi everyone, I'm going to set the scene for you all. We've all just waited 2 hours in line for the new roller coaster in town. We've just taken our seats. So if I could have everyone grab your harness and pull it down. All right. Performing visual scan. All clear. Enjoy your ride. All right, let's go up. And no hands as we go down. Whoa! To the left. Whoa! To the right. Whoa! And all right. Hi, everyone. This is my partner, Maggie Bryan. She is a junior at UConn studying electrical engineering.
And this is my partner, Henry. He's a sophomore studying computer science.
And today, we're going to be talking to you about the physics of roller coasters. So we're going to start off with the energy involved in roller coasters, and then we're going to move on to the forces, and then we're going to ride the King de Ka, the tallest roller coaster in the world.
So first, we're going to start and talk about energy. So there's two different types of energy. There's kinetic and potential, and both work together to give you the total energy of a system. So Henry's going to talk to you about potential energy.
The potential energy is the energy that is stored within and it's ready to be used later. So you can think of this as an invisible energy. You can't see it, but it's there and it's ready to be used. And this can be calculated through this equation right here, that the potential energy equals the mass, which is how much matter or how much stuff you have in you, multiplied by gravity, which is a constant force that affects all of us and it keeps us on Earth. So everyone on Earth is experiencing the same gravitational force. And this is multiplied by the height, which is how tall we are compared to the ground. So if we have a high height, we have a high potential energy, whereas if we have a low height, we have a low potential energy.
And the second type of energy is kinetic energy. So kinetic energy is moving energy. It depends on how fast or how slow you're moving, or the mass, the amount of stuff that's in you. So the equation for kinetic energy is this, 1/2 mv squared. And like Henry said, m is the mass. It's how much stuff there is in you. There's a different amount of stuff in you than in you compared to the cart. And finally, velocity. Velocity is how fast or how slow the cart is moving. So if you're ever going really fast or you're going down the hill, you'll have a high velocity, which means you'll have a high kinetic energy. And if you're going slow, you'll have a low kinetic energy and low velocity. So together, the total energy is the kinetic plus the potential. And this makes up the total energy of the roller coaster or of a system. So you can think of this as an hourglass. So in an hourglass, the hourglass changes sides and the sand moves from top to bottom, bottom to top. But the amount of sand inside of the hourglass stays the same. So you can think of this as energy. So you can think of the top as kinetic energy, the bottom as potential energy, and the total amount of energy stays the same, which is the sand. So you can see how it moves and changes. So the sand changes from top to bottom, but it doesn't change the amount of sand inside the hourglass.
Awesome.
So now we're going to talk about on the ride, how it's moving. So at the top, there's a high potential energy and low kinetic energy because you're slowing way down and yet you're at a very high height. But as we shoot down the side of the roller coaster, your kinetic energy skyrockets and your potential energy decreases rapidly because you're going down farther.
Yeah, so we just learned about the energy in roller coasters, so now we can move into the forces that come along with them. So roller coasters are notorious for creating intense acceleration and high g-forces. And these g-forces have the potential to turn your delicious fair food into high-speed projectiles. But you may be asking yourself, what exactly is a g-force? And it's actually a really simple concept. So when we're at the top of the roller coaster, we're not moving up or down, and we're experiencing 1 g of force, just like all of us on Earth are experiencing 1 g of force. But as we take the plummet down the roller coaster, and there are a lot of forces acting on us, there are multiple g's of force that we feel.
Right.
And these fluctuations in g-forces can make us feel either weightless or heavy.
So when you're on the ride, you experience two forces. So right now, we're all experiencing the gravitational force. It's the force acting on us, the chairs, the tables, everything around us. So this is the gravitational force. Does anyone know, there's also an equal and opposite force that acts upward. We didn't talk about it, but does anyone know the name of it? What is Normal force.
The normal force.
Wow, great, the normal force. So this normal force acts equal and opposite to the gravitational force. So these are the two forces acting on you when you're on a ride for a roller coaster.
And these two forces allow us to either feel weightless or heavy. So say we're going around a loop, and at the top of the loop, the normal force is pointing downwards as well as the gravitational force. And this sum of forces allows us to feel weightless. But as we travel around the loop and we're at the bottom, the gravitational force is pointing downward, and there's a high normal force pointing upward, which makes us feel very heavy.
So now we're going to look at this graph. It looks a little scary, but you can think of the bottom one as the height and the top one as the amount of g-forces. So the yellow line is 1 g of force. So that's what everyone's experiencing now. If you go above that, you feel heavy. If you go below that, you feel weightless. So now we can pretend that this is the roller coaster. So we're going to break it up into sections.
Mm-hmm. So as we're climbing up the roller coaster, we experience 1 g of force because we're not accelerating either slower or faster. But as we take the plummet down, we can see that we drop below 1 g of force. We actually feel weightless. But once we hit the bottom, our amount of g-forces skyrockets really high, and we feel very heavy. And then throughout the ride, this fluctuates until we return back to our 1 g of force.
So now that we've talked about energy and forces, we're going to apply this to the largest roller coaster in the world, the King de Ka. So the King de Ka is located in Six Flags in New Jersey. It's pretty close to us. It reaches speeds of 128 miles per hour in 3.5 seconds. It's 456 feet tall, and just to put this in perspective, that's 1.5 Statue of Liberties. So all right, let's get riding. So while you're riding, let's think about the g-forces, the kinetic energy, the potential energy, all those things we just talked about as we're on the ride.
Stop right here. So at this moment, the potential energy is very high because we have a very high height.
And the kinetic energy is very low because we aren't going very fast.
And at this point, we're feeling about 1 g of force. So let's continue. Stop. So at this point, we're experiencing a very low potential energy because we're very low to the ground.
But our kinetic energy is very high because now we're going very fast.
And at this point, we're feeling very heavy, and we're experiencing multiple g's of force.
All right, let's keep going. Congratulations, you just rode the King de Ka, the tallest roller coaster in the world. That's pretty cool. So now let's look at the King de Ka from a farther back perspective. So at the top, we said that we had high potential energy because our height is very high, but we had low kinetic energy because we're going pretty slow. When we get to the bottom, we have high kinetic energy because now we're going really fast, and we have low potential energy because we're close to the ground. At this point right here, we didn't stop here, but we can still talk about it. We have an increase in your potential energy because you gained some height from there to there, and your kinetic energy has decreased because it had to climb up that big hill. So, great job!
Yeah. So we all just learned about the energy that's involved in roller coasters, we learned about the forces, and we rode the tallest roller coaster in the world.
Pretty cool.
Yeah. So in summary, kinetic energy and potential energy work together to create all the roller coasters that we ride and love today.
Thank you.
Thank you.